Hello and welcome to the briefing room. My name is Skarbek and I'm CEO of Climateworks Centre at the Monash Sustainable Development Institute. Thank you for joining us for our final briefing room event of the year. Today we'll be discussing Climateworks' new updated decarbonisation scenarios for Australia. First though, let us begin by acknowledging the traditional owners and custodians of the lands and waters from which everyone is dialing in today. I'm joining from Wurundjeri land, and I pay my respects to their elders, past and present, and extend my respect to any Aboriginal and Torres Strait Islanders joining us today. And I acknowledge that sovereignty was never ceded. Please use the chat to tell us where you're dialing in from. To today's topic. Last week, for the first time since 2020, Climateworks released new, updated modelled scenarios that show how the Australian economy can decarbonise in line with the Paris Agreement. These scenarios are not forecasts, but rather indications of what is possible with swift, coordinated action. And they show what the new scenarios indicate is that Australia can still do its part to help the world meet Paris Agreement goals of limiting warming to well below 2 degrees Celsius and to strive for 1.5 degrees. They also show that Australia needs to pick up the speed of decarbonisation in order to achieve those Paris goals. Australia's commitment to reach net zero by 2050 currently is just in line with the well below 2 degrees edge of the Paris Agreement goals. But the 43% emission reduction target for 2030, that's the current federal target, falls just outside of the bounds of the Paris-aligned action that you'll see our evidence shows are the Paris-aligned pathways for reaching net zero in Australia. We've modelled those pathways for achieving alignment with 1.5 degrees, which is the faster end of the Paris Agreement goal, and with the well under 2 degrees. And over the past few years, we've seen the world gravitate towards solving for the 1.5 degrees Celsius edge of the Paris Agreement goal range, and with good reason. The latest science from the IPCC shows that the climate harm that was once attributed to the upper end, the well under 2 degrees temperature threshold, and the environmental harm and economic and physical and health harms that come from what the scientists show is caused by that degree of warming. When that science was updated recently, after the first one 7 years earlier, it showed that those harms would actually come to arrive sooner at the 1.5 degree temperature threshold. And therefore, it shows that the more we know about the science, the more we know about the degree of harm and the sooner we need to avoid it. And thankfully, the international community has lately recognised the importance of this and is aiming for 1.5 degrees Celsius as the maximum limit of the Paris Agreement goals. For example, some of the most powerful international alliances, such as the GFANZ, that's the Glasgow Financial Alliance for Net Zero, and the Science Based Targets Initiative have set 1.5 degrees Celsius as their standard, which is driving many of the commitments that the international financial institutions are making now and how they will measure net zero commitments and what they expect from companies that they invest in and lend to. So the new scenarios that Climateworks Centre is publishing and presenting today identify the pathway for Australia to do its part in achieving that 1.5 degree aligned Paris goal, as well as the well under 2 degrees limit on warming. So in this next hour, you'll hear from my colleagues. Firstly, Wei Sue, who will give more colour about the modelling that we do here at Climateworks and what has changed since our last scenarios released in 2020. And Michael Lee will then take you on a deep dive into our updated 2023 decarbonisation scenarios. And finally, Malos will share a bit more about what these findings mean for Australia's policy agenda in the next few years. We will also have the opportunity to take your questions at the end. So please do send them in through the Q&A section at the bottom of your Zoom screen. So to get us started, it's my pleasure to introduce you to our first speaker, my colleague, Wei. Wei leads Climateworks' strategy team, where she champions the organisation's strategic goals, as well as oversees our research and modelling capabilities. Before she led our strategy team, she headed our sustainable corporates team and supported the Australian Industry Energy Transitions Initiative, which created decarbonisation pathways for heavy industry in Australia. So Wei, it's over to you to tell us about the Climateworks Centre modelling past and present.
Thank you, Anna. As some of you dialed in might know, Climateworks has had a long history of modelling decarbonisation scenarios for Australia. And in fact, even before decarbonisation scenarios took centre stage, we started using marginal abatement cost curves back in 2010 when we published the Low Carbon Growth Plan. It prioritised individual emissions reduction opportunities on the basis of cost per tonne of emissions reduction, and importantly, represented one of the first comprehensive whole-of-economy plan for Australia to reduce its emissions. This evolved to the Deep Decarbonisation Pathways project, which we released in 2014. This was done in collaboration with the Australian National University and as part of a global network of 15 country teams through the UN Sustainable Development Solutions Network. It was a collective effort across multiple research institutions, bringing together bottom-up sectoral models in a national economic model, looking at the Australian economy in a low-emissions future. From there, we then formed a partnership with CSIRO to jointly develop the AusTimes model and released Decarbonisation Futures in 2020. This provided emissions trajectories for the whole Australian economy, as well as granularity for major sectors within that. Decarbonisation Futures demonstrated how progress in the 5 years leading up to 2020 had closed the technical gap, making it possible to achieve zero emissions in many sectors and decarbonise in line with limiting global temperature rise to 1.5 degrees Celsius. While our goal for 1.5 degree hasn't changed, our decarbonisation pathways have changed over time due to a number of factors. These include changes to the climate science and carbon budget, emergence of new technologies, and changes to current technology performances and costs. Taking best current available information of all of these to update scenarios regularly is important to reflect the dynamic nature of these factors. And since our last economy-wide pathways release, there have been some major developments. The science on global warming is much clearer, and there is now growing consensus and greater momentum around the need to aim for 1.5 degrees rather than 2 degrees to avoid some of the worst effects of climate change. The policy context has also shifted. Australia has committed to net zero emissions by 2050, and there is more action and commitment globally. We also recently worked closely with major industry partners to complete the Australian Industry Energy Transitions Initiative, producing net zero pathways for 5 key heavy industry supply chains. Through this and other parallel developments, hydrogen is now better understood and more accepted as a potential solution for hard-to-abate sectors such as industry itself. Other updates that have also been included in our model, informed by some recent projects and contract work for governments and organisations, including the Australian Energy Market Operator, as well as corporate clients, including energy companies and financial institutions. These changes have all been brought into our latest set of decarbonisation scenarios to show what ambitious, Paris-aligned action could look like for the Australian economy. Of the infinite number of possibilities, we picked 2 scenarios that represent 2 possible futures where the Australian economy is aligned with our commitment to the Paris Agreement. And these are a 1.5 degree aligned carbon budget and a well below 2 degrees carbon budget. These are brought to you today based on the best available information that we and our partners have access to. And we know that there can be limitations, which is why we will continue to update our scenarios in the future as better information and modelling tools become available. But it is our hope that the scenarios we've just released are timely and can inform key moments for Australia, including our government's NDC submission and the development of sectoral pathways, which the government will be releasing next year. So without further ado, I'll now hand back to Anna to introduce our next speaker, who can take us through more of our findings. Thank you.
Thank you very much, Wei. And thank you for that introduction. To those who now are keen to hear a little more about the scenarios, and we understand they're coming at a really timely moment for multiple efforts from private sector and public sector gearing up to create national net zero plans for sectors and for companies. And we're delighted to be able to contribute to the evidence base of what can be achieved in this collective effort. So let's look into this with our second speaker, Michael Lee, who will give us a more in-depth look at these new scenarios, the 2023 decarbonisation scenarios for Australia. Michael is our Research and Analysis Manager at Climateworks Centre, and he supports and coordinates the research, modelling and analysis that we do here at Climateworks. He's also the lead author of these new 2023 decarbonisation scenarios. So over to you, Michael, to tell us more about them.
Thanks, Anna, for the introduction, and hello, everyone dialing in. As Wei and Anna mentioned earlier, last week we were very excited to release Climateworks Centre's decarbonisation scenario 2023. These include modelling results from 2 scenarios for Australia to align with the Paris Agreement. And I'll talk you through these 2 scenarios and their results now. One of the scenarios is shown here in the purple line, where Australia reduces its emissions in line with keeping global temperature rise to well below 2 degrees Celsius. For our modelling, we've chosen 1.8 degrees to mean well below 2 degrees. The other line in the orange is where Australia reduces its emissions in line with keeping temperature rise below 1.5 degrees. When you look at this chart, the 2 lines show the range, or the upper and lower bounds, of what alignment with the Paris Agreement means for Australia, according to our modelling. We've used a modelling tool called AusTimes to produce these lines, which, as Wayne mentioned, we've developed over many years with the CSIRO, drawing on modelling approaches by the International Energy Agency. And both of these scenarios draw on the latest data we have available on Australia's historical emissions, which is shown in black on this chart here. Both of these scenarios also assume that Australia's economy continues to grow and that we can continue meeting higher and higher energy demand over time. You can see here that decarbonising in line with 1.5 degrees of warming, shown in the orange line again, means much faster reductions in emissions compared with the well below 2 degree temperature goal. This includes reaching net zero emissions for the whole of Australia's economy in the late 2030s, or in our case, 2039. Which is more than a decade earlier than the well below 2 degree line, which reaches net zero emissions in 2050. We know that even the well below 2 degree scenario represents a level of decarbonisation that's faster than we've ever seen before, and that the 1.5 degree scenario is even more ambitious. But every small increase in global temperature rise that we can avoid is important to lower the risk of severe climate impacts. And our modelling shows the level of ambition that's both possible and necessary to help keep climate change in check. It's important for us to emphasise here that it's not just the net zero date that matters when it comes to meeting our Paris Agreement commitments. To stay under 1.5 degrees or well below 2 degrees of warming, it's more critical for us to constrain the total amount of greenhouse gases that we emit into the atmosphere over a period of time. Because of this, we also use our scenario modelling to offer insights and advice on what we call interim targets, or the emissions reductions at particular milestone years on the way to net zero emissions and beyond. Our modelling figures out the overall emissions pathways between now and 2050 that minimises the overall cost to Australia's economy in a way that also limits the total amount of carbon emissions so that we stay below 1.5 or well below 2 degree temperature limits. We call this limit on total emissions the carbon budget. Australia and the rest of the world are working right now to set and agree emissions targets for 2035. So let's zoom in on our modelled emissions in that year. Our modelling shows that between 62 and 85% is the range of Paris-aligned emissions by 2035 for Australia, compared with 2005 levels. Scrolling back to 2030, our modelling also shows that if Australia doesn't strengthen its 2030 target and bring its net zero commitment earlier, the 2035 target would need to be even stronger. And to put some numbers against what I mean here, the Australian government has legislated a target of 43% below 2005 emissions by 2030, whereas our modelling shows a range of 48 to 66% below 2005 levels by 2030 in order to align with the Paris Agreement. As I mentioned before, our 1.5 degree scenario also shows Australia reaching net zero emissions in the late 2030s, which is over a decade earlier than Australia's current target of net zero emissions by 2050. Our modelling also shows that action across all sectors of the economy is needed to decarbonise in line with the Paris Agreement at lowest overall cost. This is true whether we're referring to our well below 2 degree scenario or our 1.5 degree scenario. To highlight this, when you consider the total emissions above the zero line from buildings, transport, industry, agriculture, and land, and you ignore any additional removals of carbon dioxide from the atmosphere from actions like carbon forestry, that's all shown in the dark green wedge, the emissions from those sectors above that zero line reduced by around 60 to 70% below 2005 levels by 2035. By 2050, the total emissions from those above the line sectors reduces by around 8% below 2005 levels. Just a reminder again that here we're referring to emissions from buildings, transport, industry, agriculture, and land, ignoring the carbon removals that are shown in the dark green wedge. As you can see from the coloured wedges above the line, different sectors decarbonise at different speeds. And this is actually one of the biggest advantages of the modelling approach that we've taken, because it can give us an idea of the relative contributions of different sectors to overall decarbonisation efforts in a way that reduces overall costs. When we compare the two scenarios side by side, we can also see that buildings, which is shown in the purple wedge, and electricity, which is the dotted yellow line, decarbonise pretty rapidly regardless of which Paris line temperature goal we're aiming for. This suggests that no regrets areas for action include focusing on decarbonising electricity through investment in renewable energy and phase out of coal and gas by the 2030s, along with faster investment in energy efficiency and electrification of buildings. On the other hand, stepping up in ambition from our well below 2 degrees to our 1.5 degree scenarios does involve earlier and faster adoption of decarbonisation solutions in transport and industry. And this is through things like higher uptake of electric vehicles, faster replacement of industrial gas equipment with renewable powered electric alternatives, and earlier adoption of green hydrogen in specific uses like mining equipment, alumina and ammonia production, and fuel cell vehicles for long haul trucks and freight trains. As I mentioned before, our scenarios do include significant amounts of emissions reductions from buildings, transport, industry, agriculture, and land sectors. A reminder that this added up to around 80% below 2005 levels by 2050 from all those sectors. Our modelling does also find a significant role for carbon dioxide removals, which we've defined as land management practices like forestry and a speculative technology called direct air capture, which all absorb carbon dioxide and store it from the atmosphere. We found that these carbon dioxide removals play an especially big role when keeping keeping global warming below 1.5 degrees, which in this scenario, which absorbed more than 3 times more carbon dioxide from the atmosphere by 2050 compared to the well below 2 degree scenario. While carbon dioxide removals do complement rather than replace efforts to reduce emissions from other sectors in our modelling, we do also acknowledge that the unprecedented scale of carbon dioxide removal activities represented in our scenarios present significant practical challenges. Some of these challenges include how to manage the competing economic, environmental, and cultural values that our land provides to us, plus the risk that further heat waves and future heat waves and flooding, which the climate science predicts will become more frequent because of climate change, will affect nature's ability to absorb and store carbon. I'm glad to say, though, that to address some of these challenges, at least in part, we at Climateworks are currently working with Deakin University to update what we call the land use trade-offs model that will complement and stress test the scenarios that we're showing you today. As time goes on, we'll keep updating and evolving our scenarios that I presented to you today to keep pace with the latest data, the latest research and knowledge as it comes up. And with that, I'll hand back to Anna to take us through to our next speaker. Thank you, Anna.
Thank you, Michael, for the overview of the scenarios. And those of you watching online with a screen may have noticed the graphics have an interactivity that Michael was clicking through. And when you click on the links at the end of this session and find the reports online, all of our charts have this new dynamic ability to follow in an interactive way, part of the 2023 upgrade, not just to the evidence, but also to the format. And thanks for our team for helping make it so easy to digest for listeners and for users. If you have just joined us for listening in today, Welcome to Climateworks Centre's briefing room, where we're talking about our new scenarios modelling showing how Australia can decarbonise in line with the Paris Agreement. The updated scenarios from 2023, the first time since the last time we did this in 2020. And I'm Anna Skarbek, the CEO of Climateworks Centre. So you've heard earlier from my colleague Wei about Climateworks' decade-long history of using scenario modelling to encourage climate action in Australia. And we've just heard from Michael about the latest results of the updated modelling, which shows how Australia can decarbonise on the least cost pathway using the latest cost data for the technologies in each of the sectors. And running scenarios about the Australian economy that shows that the economy continues to grow and to meet energy demand, while we can decarbonise each of the sectors in the economy that are currently creating the emissions. And so what we're looking into today is what does that look like and how do we do the decarbonising while continuing to create a prosperous net zero future. So if you have a question about any of this, please do submit your questions via the Q&A button in your Zoom screen. We've got one more speaker before we'll open up for the Q&A session. And that speaker is our colleague, Anna Malos. Anna leads our Australia country context and helps understand the political and economic landscape. Before joining us here at Climateworks, Anna was Assistant Director at the Climate Change Authority and also worked on climate policy as Director of the Climate Action Network Australia, CANA, and also in the Victorian Government. So it's over to you, Anna.
Hello, and thank you. So over the next 2 years, both governments and businesses have deadlines for actions. So I want to talk to you about how our work can inform their decisions. Under the Paris Agreement, each national government is expected to set interim emissions reduction targets and a long-term plan to reach net zero emissions. For the interim targets, this happens on a 5-yearly cycle. So in 2025, the Australian government will be letting the world know its 2035 target through the United Nations. The government is also committed to revising its long-term net zero plan and in setting in place policy to meet its commitments to reduce emissions. And the government has committed to aim to exceed its current 2030 target. As part of this work, to decide Australia's targets and to ensure they can be met, different federal departments are leading on 6 sectoral plans. This work will be in consultation with the states and territory governments through relevant lead ministers. And in addition, the Climate Department, or DQ, has joint responsibility for the sectoral plans and is responsible for drafting the overall Net Zero 2050 plan. To support these decisions, the Climate Change Authority, an independent part of government, will be providing advice to government. This includes through sectoral decarbonisation pathways, so pathways akin to the work that we've just presented, as well as broader research into the international economic context and opportunities. So right now, and through much of next year, all Australia's governments will be working on their plans and on their policies to reduce emissions across the economy. So our work shows what they can aim for. Now, businesses will also be acting. Now, this is because of compulsory changes to corporate governance. This is initially on what's known as mandatory disclosure or disclosing climate risk, as well as in the future, they'll be reporting on their plans to reduce emissions, which are known as credible transition plans. Businesses are also acting voluntarily because they know they need to keep their customers and investors. In other words, to maintain their social license. And that's by showing their emissions reductions plans are in line with what's needed. So again, our work can provide guidance. We show what action in line with Paris can look like and what these businesses and governments should be aiming for. So what does our work show? I mean, initially it shows, or most importantly, it shows early reductions matter. And this is particularly in the energy sector. Also, early action creates momentum for further change. Technologies become cheaper, you get that kind of win-win, and you start to have real momentum. Now, all sectors have opportunities to decarbonise, but we've seen that these sectors decarbonise at different rates. So ensuring the electricity sector rapidly reaches near zero underpins actions in other sectors. And while there are similarities in the sectors for the two scenarios, where there are similarities, this reflects that these sectors have some of the lowest cost emissions reductions and readily available technologies. Now, Michael referred to these as no regrets actions. I also like to think of them as no-brainers. It makes sense to act regardless of the temperature goal. And in some cases, they're also more, they save you money and reduce costs. There are reductions in other sectors, especially in agriculture and transport, where increases in activity can hide the emissions reductions, so that for each unit of activity, you are getting fewer emissions, but overall it looks like it's similar because that activity level has increased. So now I'm going to talk through a little more detail in the different sectors. First off, energy. Now, as I mentioned, there are these no regrets or no-brainer actions, and energy is one of the obvious areas, particularly in the electricity sector. So switching to generation to renewable energy reduces about 1/3 of emissions. Making electricity clean and switching from fossil fuels to these renewables then not only reduces the direct emissions, but allows you to electrify across other sectors. And that drives change across, a number of other sectors and accounts for another about 1/3 of emissions reductions. Now, at the moment, there's an emphasis on the 82% goal for a share of renewable energy in renewable electricity in 2030. In our work, least cost pathways move even faster. So, and one of the things that we show is that across the length of the scenarios, because you're really scaling up the use of electricity, then actually renewable energy generation needs to be 3 times as much as all electricity generation in 2020. And that's where you get this idea of kind of 300 or 500% renewables. It's about a comparison to all electricity renewable generation in 2020. Australia, in the energy sector, Australia also needs green hydrogen to enable change in activities and industries that are otherwise hard to abate, where you can't just electrify. For buildings, it is pretty much about electrifying. So you also need to combine that with improving energy performance of the building themselves. So better insulation and, shading to keep out the heat in summer. But otherwise, buildings decarbonise very rapidly as the grid becomes fully renewable and as you switch from gas to electricity. In transport, this is one of these sectors where big changes are kind of almost hidden by the fact there will be higher activity as our economy grows and our population grows. Light vehicles switch to electric vehicles. Freight can be more complex. It's either electric vehicles or hydrogen. And we're really looking for the government's fuel efficiency standard to kind of help lead the way in this area and drive change, not only to make EVs more affordable, but also improve energy efficiency in other vehicles so that we all get to pay less for our fuel consumption. EV uptake is the main difference between the two scenarios. In a 1.5 degree scenario, you get faster uptake of EVs. In industry, and this includes the resources sector, so the government is doing plan for both industry and for resources. In here, energy efficiency, again, reduces emissions and costs, much as in buildings. Renewable energy, either on-grid or on-site, reduces emissions from existing power use. You get fuel switching, mostly to electricity from coal and gas, but also to hydrogen. And hydrogen is particularly important in some areas where they need higher levels of heat, known as high process heat, and it's hydrogen that is the better solution in these areas. There also needs to be novel processes and new technologies to reduce process emissions. So this is where the production process does create greenhouse gas emissions other than through energy use. Finally, I'll just mention agriculture and land. Again, this is a sector where increasing activity can kind of hide the fact that there is a lot of change happening within agriculture. And so the ways to reduce emissions in agriculture are particularly around livestock. So this is the feed stuff that Michael mentioned, and there's a variety of ways to reduce methane emissions from livestock, and also better fertilizer use. And this is win-win, it's lower cost for farmers and you're getting less runoff of nitrogen, and you're also getting fewer greenhouse gas emissions. So sometimes you can improve productivity and reduce emissions, and obviously that's what you're looking for. And the government has released a draft agriculture and land plan already, one of these sectoral plans, and they're out to consultation at the moment. And they've also got a nature positive agenda. So we're really looking for our work to influence what the government sees as the possibilities. This is a global challenge about how to feed a growing global population whilst reducing environmental damage. And Michael will talk you through, nature-based solutions. So that's removing carbon from the atmosphere and storing in vegetation in soils in a way that benefits, the benefits go well beyond carbon emissions. So now I'll pass back to Anna, and we will answer your questions.
Yes, thanks very much, Anna, the other Anna at Climateworks. And I am going to invite all of our presenters today. Thank you. You're coming back on screen. And we have had a heap of questions. So looking forward to working through as many of them as possible. I'm going to start with one of the overarching ones that came in. And Michael, I'll ask you to take this one. And the question was, how do you work out Australia's share of global emissions reductions to fairly hit the Paris targets?
Yeah, thanks, Anna, and thanks for the question from the audience. Just to get, I guess, a bit of background to that question as well for others who might not be familiar with this concept. I mentioned the concept of a carbon budget during my presentation around the total cumulative amount of emissions that can be emitted over time before we reach certain temperature limits. That's normally calculated at a global level. And the question is, how do we allocate the portion of the global carbon budget to Australia so that Australia is playing its fair share towards the global efforts? The methodology that we use is consistent with the methodology that's been used in the past by bodies like the Climate Change Authority, and is consistent with methodologies used by experts at Melbourne University who are involved in the IPCC's climate science, Lighthousen and Nichols, who use what's called a modified contraction and convergence method. And what that means is that essentially there's some modeling assumptions that they do where they make an assumption that at the moment some countries have higher emissions intensity than others to produce their emissions and to kind of meet their economic growth. But eventually over time, the more emissions intensive countries become less emissions intensive, while also the countries that are less emissions intensive and I guess have lower levels of development have a little bit of leeway to become a bit more emissions intensive to meet their broader development needs. And over time, all countries meet the same level of emissions intensity in the long term. And what they've calculated based on this really complicated method is that Australia's share of the global carbon budget is 0.97% of that global budget. And that is essentially the calculation that we've used with a few minor adjustments here and there to account for different time that the data is valid from and so on, to then calculate the carbon budget for Australia that we've used in our modelling.
Thanks, Michael. There are a lot of questions, Michael, that are going to come your way. And as lead author of the report and lead of the analysis, I'm not surprised about that. I'm going to allocate one to you, and then a couple to the others, and then there'll be many more to you as well, Michael. One has asked, how does this modelling compare to other work that Climateworks Centre has been involved in through the Australian Industry Energy Transitions Initiative, which we call the ETI? What are the key similarities and differences?
Yeah, so the ETI work is the Australian Industry Energy Transitions Initiative. That represented a collaborative piece of work where Climateworks and partnered with Climate Kick and a whole bunch of industry partners to model emissions reduction and technology pathways for heavy industry, a series of specific supply chains within heavy industry, including LNG, steel, alumina, and a couple of others. And through that work, Climateworks did a whole range of literature review and research on the specific emissions reduction opportunities in those hard-to-abate sectors, things like the use of hydrogen, the use of really novel technologies that hasn't really been found to be cost-effective previously. There's a much greater acceptance and understanding of the opportunities those technologies now provide, particularly around hydrogen for those hard-to-abate sectors, and work with industry to get, I guess, a common set of assumptions around what the costs and opportunities are in those sectors. That represented an update and improvement on the modelling we'd done previously through decarbonisation futures back in 2020, which Wei mentioned was our previous iteration of our scenario results. And for the scenario results that I presented that we published last week, they have utilised, they've drawn on the assumptions and the data that was collected as part of that ETI. So essentially, it's building on the work that was done for ETI, noting that the ETI work was focused on those particular supply chains within heavy industry. The scenarios we've presented now talk about, well, how do those opportunities within heavy industry contribute to Australia's broader decarbonisation, and what does that broader decarbonisation look like with those opportunities in mind?
Thank you. We've had quite a few questions about sectors. So there's many around agricultural land and nature-based sequestration. And in a moment, I'll pass some of those to you, Anna, and there may be some more for Michael. And there's also a transport sector question. And so before I come back to Michael, I'll go to Wei with a question for you. Is there a reason you chose to model slightly different sectors than the government's announced sectoral plans, pathways for net zero?
Thank you, Anna, and thanks for the question. Basically, this goes back to some of the sort of history and how we've come to build the model AusTimes, as I mentioned earlier during this session. So we've had a near decade-long history working with CSIRO, starting from when we jointly developed the AusTimes model, which represents an Australian adaptation of the IEA ETSAT model that is also used for various IEA scenarios that many of you might be familiar with. And in doing so, we did have a choice around what sectors and categories we wanted to build into the model. And the choices of sectors that we have used and that you do see in the results that we shared with you today basically represent a more intuitive way of thinking about end-use sectors and the way businesses, lay people sort of relate to the Australian economy and where we use energy or generate emissions. They do differ quite a little bit from the greenhouse gas inventory that our government as well as other jurisdictions published, but do represent a more intuitive reflection, I guess, of scope 1 and 2 emissions. So it actually does distinguish that. For example, the wedges that you see in our results represent where energy is used and where emissions is where the emissions are responsible, or where the entities are responsible for those emissions, if you like. And we use a sort of line instead to represent emissions associated with electricity generation. And that also speaks to where the opportunities may lie around how emissions can be reduced as well.
Thank you. I've been trying to group the questions around the agriculture sector. And so, Anna, I might invite you to share the overview perspective around the approach we take to the agriculture sector and nature-based sequestration. Mm-hmm. And then, Michael, there are a number of questions around what have we taken into account regarding climate impacts on the land and the elements of sequestration around nature-based credits. And so I might ask you to speak. I know we have more modelling underway in relation to the land sector. So given how many questions there were, let's have a double answer on this one if you'd like to open, Anna, and then hand to Michael.
And I'll just add one more thing to what Wei was saying about how our modelling relates to the government sectors. It is worth noting that the government is separating industry and resources. Now, for us, that's all within the industry sector. So we probably can separate out those. but we haven't done so to date because, as Wei said, we've used them, we've fitted in with our traditional approach. Now, on agriculture and the land sector, so the modelling does combine two things. So there's modelling of the agricultural sector itself, and so that's the, whether it's methane or nitrous oxides, what activities and energy use, what activity is happening within agriculture, and does apply a number of technologies to try and improve emissions reductions. And you do see some substantial shifts in the emissions, per unit of activity, if you like, whilst agricultural activity grows. Now, in the land sector, we take two approaches. So one, the kind of forestry and sort of forest activities happen within OzTimes. But then we also look at how else you can reduce carbon dioxide from the atmosphere using land-based activities. And that's in the LUTO model that Michael mentioned. So that was work with Deacon, with CSIRO in the past, looking at how to get the lands, how much more can happen in the land sector. Now, this is being updated, as at the moment, and we have done some rough testing to see that those levels of land-based carbon dioxide removals are still, they're very radical, they're very challenging, but that's the kind of action we need in this space, because we really have to get our emissions right down to zero. And so it is that kind of combination of things happening in agriculture, things happening in existing land uses, and also additional land practices to get, more vegetation, new forests, better vegetation on the land, and also higher levels of sequestration in the soil. But we'll be looking forward to next year saying more on that and having a much more kind of sophisticated approach. I'll pass to Michael if he wants to add.
Thanks, Anna. Yeah, and one of the great advantages of the work that we do at Climateworks is that we do have multiple tools, models, analytical approaches that we can draw on to get different insights. And in particular, we have these two really powerful modeling tools that we have exposure to and access to. One being OzTimes, which we use to model the scenarios that we presented today. The other one being LUTO, the land use trade-offs model, which I can talk about, and a couple of us have mentioned already. The OzTimes model is really great for providing that high-level view over what overall emissions reductions can look like in the context of meeting the goals of the Paris Agreement and meeting the carbon constraints of the Paris Agreement, and how that is balanced across different sectors of the economy. When it comes to the way that land and agriculture and carbon dioxide removal sequestration are represented in OzTimes, it's very much represented by a few different technologies around reducing agricultural emissions, like feed additives, like the way in which you sustainably manage your land and rotate your grazing and your crops, and the way that you manage your fertilizer and different kinds of fertilizer technologies to reduce emissions from agriculture, and they're costed options to the model to actually add to this whole kind of suite of measures it can use to reduce emissions over time. We also represent the costs of the efforts to reduce emissions and absorb emissions through forestry and soil carbon and other measures as well. So there's a great representation of those costs and those options in OzTimes and how that kind of compares with other sectors of the economy. Having said that, the really powerful thing that LUTO is going to provide is that it's what's called a spatial model. So it can actually go beyond that kind of high level view that OzTimes provides and go into the spatial detail. And what I mean by that is looking at each individual parcel of land across Australia. What are some of the local environmental and economic and kind of social conditions that apply to that land? And how does that relate to, I guess, the most economical, the most appropriate use of that land, and then aggregates that across the whole country to understand, okay, what sorts of emissions reduction measures are possible in different parts of the country, where is that possible, where is it more profitable than others, and it actually combines a whole bunch of other options to use that land, like using it for farming or for other productive uses, or it's a very, very rich model and data set that we can draw upon to answer that question of, okay, well, we have from OzTimes an idea of the overall scale of the role that the land sector can play in supporting emissions reductions. Luta will help to answer the questions of, well, is that possible? How and where could those measures be put in place?
Thanks, Michael. Great overview. And Anna, earlier, I've been quite close to the work with Luto and what we're calling Luto 2, which is this upgrade, which will go into even more depth about the spatial ability. And in particular, it's adding another question that we're solving for in addition to the ones you've outlined, and that includes biodiversity and natural capital, recognising that while we need to achieve net zero emissions on the land and involving land-based sequestration, we need to have a much greater understanding about what it means for also maintaining a nature positive economic system and the ecosystems, the physical nature that supports us. So I'm excited that the work that our colleagues have done with collaborators that adds, for example, 10,000 species extra into the modelling ability to understand the impacts on and therefore opportunities for maintaining biodiversity and natural capital while also achieving net zero emissions inside a net zero global economy. So if you stick with the sector focus, if we move from agriculture but stay in the realm of what we've called CDR or carbon dioxide removals, because if you looked at the green wedges in our charts, you were talking about agricultural emissions and on-farm management and also nature-based sequestration, which is the green below. There was a question, I'm going to give both of these to you, Michael. There was a question about the shape of that green wedge, which you've identified in the sequestration, nature-based sequestration. That's come from the simplified model, not yet the spatial one. And there looked like there was a bit of an inflection point after the 2030s, and was that due to a policy shift? And I think you've got some assumptions there, which you might illustrate, but that I know it comes with the caveat that we are updating this much more granular assessment of how to understand land. So I'll invite you to add that. And then while you have the microphone, the other part of CDR was a reference to DAC, direct air capture, which I know is a smaller element in the modelling, but does feature. So could you address both of those, please, Michael?
Yeah, thanks, Anna. And really great questions, because a lot of these relate to the use of scenarios and the general use of scenarios, which is that they help us to provide insights on what different potential futures could look like. But it's really important to note that these aren't prescriptive views of the future. These are really representations of what the future might look like based on a set of assumptions that we put into the model. And I'm going to use that as a bit of a theme to, I guess, talk about both the rate of change in land-based sequestration, but also the direct air capture point as well. When it comes to land-based sequestration, we've made an assumption that it will take some time for the markets around carbon offsets, for the land and the use of land to be able to switch in use in order to actually prepare for this kind of quite different and radical shift in the way that we use our land, to start to kind of get those emissions sequestration opportunities at scale. And so what we've actually assumed in the model is that for the next decade or so, the maximum annual rate of sequestration that's allowable will match essentially historical levels, and those historical levels will continue for the next decade or so. But then after that decade is passed, around the mid-2030s, we specifically switched the assumptions in the model to say, okay, now the land sector is ready to take on this extra demand, and we've set a maximum allowable amount of sequestration that ties in with some modelling that came out of the CSIRO last year around, if you actually really go 100% and full throttle, what is the maximum potential? So really, it's sort of a way for us to model a proxy for this sort of adjustment that the sector is likely to need over that period of time. Similarly with direct air capture, again, it's really based on an assumption that direct air capture technologies do become viable in the long term. It's an assumption that they will still remain expensive, but there's an assumption that over the long term, direct air capture technologies move from a speculative to a more kind of viable technology solution. That is quite clearly a big if, given that it is an unproven technology at the moment. There are limited trials around the world, and so we've included it as essentially as that speculative solution to say, okay, what if it actually did become viable? What role could it play? The answer being that it plays a relatively minor role compared to land-based sequestration, and there's reasons for that come down to things like cost and the timing as well. In that, I think Anna Malos mentioned earlier that faster reductions sooner in emissions really matter in direct air capture. Even if it does become viable, it just doesn't reach that point until the late 2030s, early 2040s. Having said that, of course, if those assumptions don't play out, if direct air capture doesn't become viable, if it remains expensive or becomes even more expensive over time, then we wouldn't see direct air capture play a role in our future. And those emissions reductions would come from other sources, maybe from sequestration, maybe from further emissions reductions in other sectors as well. And this is really the beauty of scenarios as a tool, is that we can actually, we haven't done this testing yet, but there is a potential for us to do this sort of testing and this modeling as we kind of want to investigate these questions going into the future.
Thank you. Let's, the next question I'll allocate to Wei, and that's moving beyond the sectors to the manufacture of the things the sectors use, such as there was a question, what about the emissions involved in making renewables? So the manufacture of solar panels, transmission towers and wires. Wei.
Thanks, Anna, and thanks for the question, which is essentially around supply chain emissions and Scope 3 emissions. And we recognize that this is definitely an important area, but is an area of limitation in our current model, in that it does not account for emissions that take place outside of the Australian continent at this point. And one of the reasons, again, for that is there is lots to be done around our domestic emissions to start with. And while we do recognize the importance around supply chain emissions, upstream emissions, as well as other Scope 3 emissions, that is an area of focus that we will be looking at and be investigating modeling tools that will allow us to better account for that going forward. But at this stage, as you will see from the release of our scenarios last week, as well as the reports that we've released around it, there's still plenty of opportunity for Australia to reduce our domestic emissions in line with 1.5 or well below 2, and further scope for us to address supply chain emissions beyond that.
Thanks very much. There's still more questions on what's included and what isn't. So I'm going to go to you for a couple, Michael. Wei, you were talking there about the manufacture of materials that make up our energy transmission network, for example. There's a question about how are the costs of energy transmission included in the modelling. And Michael, I know that you can answer that. And it came with a question around what about the logistical challenges with that, which goes more into policy realm. And so for those who are familiar with our work, we know that by setting out the task and the opportunity for achieving what our shared goals are around a net zero prosperous economy for Australia, we can help support many other aspects of what we call the ecosystem of shifting these system transformations, and that addressing social license is a feature of many industry conferences at the moment. There's other work around work going on inside governments, both state and federal, and in industry associations, and we know that work is underway, and it's very much part of this systems transformation effort, that when we're clear on the goal and we're clear on what the path involves, we can then allocate resources and effort and high quality thinking and community engagement and policy advice to unblock that. So that's how we'll respond to the questions around implementing these changes, but measuring them and mapping them. Michael, you, I know, have included some of the costs of the energy infrastructure in the electricity sector. So if you could address that briefly, and then we'll have time for only one more.
Yeah, that's right. So the financial costs of investing in new transmission and distribution infrastructure, particularly the transmission infrastructure for the electricity grid, is included in the modelling. It's accounted for to, I guess, account for the extra costs of increasing the capacity of the electricity grid and increasing that capacity through greater penetration and greater uptake of renewable energy. And the model does take into account those costs when it decides on what are the lowest cost options to reach its decarbonisation objectives. Having said that, and alluding to what Anna mentioned just now, the model really focuses on setting that expectation, setting that benchmark for the scale of the transition that would align with the Paris Agreement. And we would be using this as an evidence base to support other actors in the implementation side of So we really look forward to doing that over the coming years.
Thanks, Michael. We'll stay with you because whilst I said we've only got time for one more, I'm going to squeeze two in because I think our colleagues might be able to address some of it in the information that follows this webinar. So there were two questions. One was, how have we incorporated other planetary boundaries in this modelling other than climate change? And I know that Climateworks has indeed published a report on the planetary boundaries, the global analysis of planetary boundaries and what it looks like for Australia. And so our colleagues can include a reference to that in the chat if you're not already familiar with where it sits on our website. And so there was a question, Michael, of how does this modelling include it, if at all, or if not, we can refer to that. And then the other one was around the transport sector. To what extent was public transport and other transport solutions integrated into the modelling beyond EV uptake?
Two great questions, and I'm going to do the cop-out solution of deferring to other projects that are in play as well. So one is that the AusTimes tool that we used for the modelling that we present today really focuses in on carbon emissions as a planetary boundary. It doesn't have an explicit incorporation of other planetary boundaries. But as Anna alludes to, and as I can see is linked in the chat now, we do have other work going on to look at those other planetary boundaries. Our work to update LUTO and LUTO 2.0, as Anna, or LUTO 2, sorry, as Anna mentioned, we will look at those other planetary boundaries and other constraints on resources besides carbon in the way that we manage our land. So we will incorporate that into some of our other work. Similarly, on the public transport and I guess transport mode shift side of things, our current scenarios don't explore, sorry, the scenarios that I presented today don't explore the potential benefits of mode shift and public transport in addition to EVs. But again, I can signpost the work that's going on that is actually explicitly exploring that question and the additional benefits of that. So thankfully, I'm able to say we're working on those two things as well.
Yes, we are indeed. And sadly, we are at time and the questions were flying in, and I know we have a really interested audience in this, and you're right to flag other work. At Climateworks, we live and breathe this stuff. And we spend our lives focusing on what does good look like for net zero in a prosperous future for us all, and therefore what does it take to get there? And so often it raises questions which enables others to hunt for the answers. And we have teams working on, as you mentioned, the freight team recently setting out its research in modal shift for freight. And our agriculture team looking at the more detail, and each of our sector teams drilling into detail. So I wanted to thank our colleagues for both here and elsewhere in Climateworks for creating this evidence base, which helps so many others in addressing these questions and implementations. So today, our speakers that you heard from were Wei Sue, Michael Lee and Anna Malos, and the team behind the scenes who makes webinars like this happen for us, our colleagues Simon Brown, Sophie Stephanakis and Alison Porton. And all of our other Climateworks colleagues. There are, as I said, many of our staff have contributed to this work. Our analysts, our writers, our reviewers, and and we spend a lot of time engaging with policymakers and industry as well. And so we have teams working on all of that. And we know it's a vital piece in the puzzle to be able to understand where we're going, to help unleash all the solution-solving powers of those around us and those we work with. So I encourage you all to keep working on this. We can see a successful net zero future for us and our region. And so I encourage you to tune in next year when we continue our briefing series into 2024. We will create more opportunities for you to engage with our work, with more contributions to creating progress on climate solutions across Australia and in Southeast Asia. So for this particular webinar, we will email through a recording from this session and keep you updated through our usual newsletter channels on all of our work, and look forward to seeing you again at one of these in the new year. And you can find all the rest of our work on this link. Thank you. Excellent timing. The Climateworks Centre website is where you'll find all of the reports that we've referred to, and those that we are working on will be published there as well in due course. Thank you all for joining us. See you next time.